Hello friends, we are in our lecture 6. So from here, I'll tell you the basics behind image processing step by step so that you can understand it better. And here you can see there are 10 steps involved in image processing: acquisition, image enhancement, image restoration, color image processing, wavelets and multi-resolution processing, image compression, morphological processing, segmentation procedure, representation and description, object detection and recognition. So these are the steps involved in it. I'll tell you one by one what does it mean and what all it involves. So I'll just give you a very short note about it. You know, worry if you don't understand some points in it. When you get deeper into those topics, you can understand it better. So no worries. I'll just tell you fast what each one means. So in acquisition, you're just gonna obtain a digitalized image of the desired object which you wanna analyze. So that's what you do in acquisition. You're gonna scale it, or you're gonna convert it into desired color modes. You're just gonna get a proper digitalized image in the process of acquisition. And next comes the image enhancement. In image enhancement, you're gonna adjust or modify the images so that the results are more suitable for further image analysis what we are going to make. So that's what image enhancement does. And in image restoration, you're gonna uh, say, for example, if you have a corrupt image, it has some noise in it. There are many noises like Gaussian noise or salt and pepper noise. So you're just gonna remove those noises with some algorithms, and you're gonna get a cleaner image. In enhancement, you can even remove the noise, sharpen it, and brighten the image, or do whatever you want to do in enhancement. So these two helps us to enhance and restore our image so that we can get a better image which can be done for further processing. So the next process is color image processing. So color image processing is nowadays very popular, and it has become very vital. So we're going to do some processing and analysis in the color modes. So then next comes the wavelets and multi-resolution processing. So what is a wavelet? But before that, have you ever heard of the term transform? You might have heard it in your signals and systems if you learned that subject. So transform is nothing but you're gonna convert a signal from one domain to another so that it could be analyzed easily in that domain. So it helps us to analyze it with ease. We're going to convert it from one domain to another. For example, you might have heard about Fourier transforms. Here in this transform, to get the wavelets, we are just going to decompose it into small waves of varying frequencies in a limited duration. So you can do some analysis with the wavelets, and in that domain you can do it. So in image compression, why do you go for image compression actually? When I'm talking about this, have you seen the memory or the space required for your movie or any video? Actually, I was watching a movie, that's why I'm asking you. So how much does it take? Around well, the movie which I was watching took around 300 MB or so. So it depends on the clarity or the resolution of the image or the video. So why do we go for compression? Actually, nowadays, even for storage of video or images, or even for the transfer of files, we need compression, so that only then we can reduce the bandwidth required to transfer it, or the storage space also. So we're going to reduce the size of the file in bytes. At the same time, we should not degrade the quality of the image or the video, right? It should be proper. The quality of the video or the image should not be degraded below a specific level. We should also see to it, and then accordingly image compression is done. Okay, then what is morphological processing? So in morphological processing, we are gonna do some analysis and processing with regard to the shape, form, and structure of it. In this, you're going to use some set theory concepts, and there'll be hits, fits, and using that, you're going to do dilation and erosion. So don't worry about all these terms. I'll tell all about this in the upcoming lectures. So we're just gonna apply some structuring element to the input image so that we can get a output image of our desired characteristics. So that's what you're going to do in this. And in segmentation procedure, what does the term segmentation tell? So we're gonna partition the image into several segments so that it would be easy for us to do some analysis in it. So we're gonna partition into multiple segments according to our purpose, according to our needs. And the next step is representation and description. So you're gonna represent the image based on its boundary and the pixels comprising the region inside the region which we wanted. So here you can see the external characteristics involve the analysis of the pixels outside the boundary, and the other one is the pixels inside the boundary. So we are just going to do some analysis like zero padding in order to eliminate the merging of the object which we want and the background. So all these things we are going to do in this representation and description. And the last one is object detection and recognition. So in this we are gonna find instances of object in an image. For example, you might have used UCam Perfect, right? So in that, when you wanna edit something, you put your picture of yours. Then when you wanna beautify your face and all, it shows some it detects the faces, right? Object detection. So this is one example of object detection where your face is being detected. You can even use this to detect some other objects like whatever notebook or a book, whatever. So these are the 10 steps. So these are some of the processes involved in image processing. Now I'll tell you in detail about the process of acquisition. So already I told you acquisition is nothing but you're going to get a digitalized image of the desired object which you're going to analyze. So mostly this image acquisition depends on the hardware. So we use cameras for getting the digitalized image. So a camera consists of sensors inside them which measures the light intensity. So there are sensors which convert the light into electrons, and there are also ADC, that is analog to digital converters inside the camera, which helps us to convert the analog parameters into digital parameters. So the sensors used may be CCD, it refers to charge coupled devices. It may also have CMOS inside them. So I'll show you the pictures here. This is the CMOS camera module. This is what is inside your camera. This is the CMOS present inside your camera, which acts as a sensor. And here, this one is the CCD, that is charge coupled device inside your cameras. So you can compare these sensors with the working of your eye. The eyes have sensors like rods and cones which capture the amount of light entering into the eye, right? Just like that, the sensors also have performs operations of sensing the light intensities. So the next picture, here you can see the illustration of image acquisition here. You can see the object here, this one, the leftmost one. This one is the object which we have to capture. So the sunlight acts as a source of energy. So it comes and reflected here and goes into the imaging system. The imaging system we use is the camera. So the camera, it helps us to convert this analog into digital one. So in this stage, you can see it in the last two parts here. We are converting it to a digitalized form. We are doing the during digitalization, you're going to do two processes. One is sampling and the other one is quantization. We'll talk about more about sampling and quantization in the upcoming lectures. So you're gonna so you can see from here, if there are more number of pixels, we could represent the accurate object we can even make it very accurate. But when there are only less number of pixels, the clarity will not be good. You can even see that in this illustration. So this is what is done in acquisition.